Example 4, evaluate the limit of e to the negative x times the square root of x as x approaches infinity. So first of all, I'm going to rewrite this limit as x approaches infinity, and I'm going to make this x to the 1/2 power all over e to the x. Now, I'm going to graph each of these functions to help me evaluate this. The square root function looks like this. So you can see here for this function, as x goes to infinity, the square root of x would also go to infinity. So the numerator would be infinity. For e to the x, that function is a power function like this. So this would be e to the x, y equals e to the x. So you can see this one, as x goes to infinity, e to the x would also go to infinity. So this is indeterminate. Which just means we can't determine what the answer is. So what we can do, we can use L'Hopital's rule, and we can take the derivative of the numerator divided by the derivative of the denominator. So now, let's see, when I multiply the numerator and the denominator by 2, you end up getting the limit as x goes to infinity, x to the negative 1/2 all over e to the x, which equals the limit as x goes to infinity, 1 over x to the 1/2 times e to the x. So when we evaluate this limit, this would be 1 over infinity times infinity, which we know that this is actually 0. So we don't want to actually write this here. This notation here is bad. So our answer is just 0. All right, example 5, evaluate the limit as x goes to infinity of 1 plus 1 over x to the x power. So if we try direct substitution, this would be 1 plus 1 over infinity to the infinity power. 1 over infinity is 0, so this would be 1 to the infinity power. That's indeterminate. Also, this is just bad notation here, so I'm just going to erase that. Keep that a big equal sign there. Okay, so now let's do this. Let's say let y equal the limit as x goes to infinity of 1 plus 1 over x, 1 plus 1 over x to the x power. Then what I'm going to do, I'm going to take the natural log of both sides. So then I would have the natural log of y equals the limit as x goes to infinity. And here we can use the power rule for natural log, or logs. So this would be x times the natural log of 1 plus 1 over x. And now we can try to evaluate the limit. This plug in direct substitution, this would be infinity. This would be natural log of 1, because that goes to 0. This would be times 0. This is indeterminate. So now I'm going to do the natural log of y equals the limit as x goes to infinity of the natural log of 1 plus 1 over x all over x to the negative first. Again, you can try to evaluate the limit in this form. Still going to be indeterminate because we didn't do L'Hopital's or anything, but this would end up being the natural log of 1, which is 0, and this x to the negative first is equal to 1 over x. As x goes to infinity, 1 over x goes to 0. So that would be 0. So this is indeterminate. So we're going to use L'Hopital's rule. So when I take the derivative here, this would be, let's see, the derivative here, let's see, the derivative of this is going to be negative 1x to the negative second all over 1 plus x to the negative first. So I'm going to have negative x to the negative second all over 1 plus x to the negative first all over. The derivative of this would be negative x to the negative second. Then you can see here, these cancel out. So now I have the natural log of y equals the limit as x goes to infinity of 1 over 1 plus 1 over x. That's the same thing as x to the negative first. Now we can evaluate this. This is going to end up being 1, as that goes to 0. 1 over 1 is 1. So now we have the natural log of y equals 1. So this is in log form. To put in exponential form, the base is e, the exponent is 1, equals y. So y equals e. So this limit here, this original limit here, this is e, which comes up quite a bit in mathematics. Example 6, evaluate the limit of sine of x raised to the x power as x goes to 0 from the right. So if we try direct substitution, sine of 0 coming from the right would still be 0, and x, direct substitution, 0 coming from the right would be 0. This is indeterminate. So now I'm going to do this. I'm going to say let y equal the limit of sine x raised to the x power as x goes to 0 coming from the right. Then I'm going to take the natural log of both sides. So I've got the natural log of y equals the limit as x approaches 0 coming from the right. And then this guy here, I'll apply the power rule for natural log. So this would be x times the natural log of sine x. And then I'm not going to evaluate it here, because if I evaluate it here, it's going to be indeterminate again, because I really haven't done anything different to this. You don't want to really apply it until you do L'Hopital's rule. In order to do L'Hopital's rule, I need to rewrite this as the limit of the natural log of sine of x all over x to the negative first as x approaches 0 coming from the right. So what I want to do, I'm taking this function, I'm moving it down to the denominator, because you need a function in the numerator and the denominator to apply L'Hopital's rule. So L'Hopital's rule, the limit of x as x goes to 0 coming from the right. If I take the derivative of this function, this would be cosine of x over sine of x, because the derivative of sine of x is cosine of x, and then it's sine x. The derivative of x to the negative first, this would be negative 1x to the negative second. Okay. And then this is the same thing as the limit as x goes to x approaches 0 come from the right. I'm going to move this up here, make this negative x squared, move this down to the denominator, which would make this sine of x over cosine x. And then the natural log of y equals the limit as x goes to 0 from the right, negative x squared all over. This would be tangent of x. So now I'm looking at these two functions. I'm looking at negative x squared. Okay, as x is approaching 0 coming from the right, that's going to be 0. And tangent function would be like this. It's also going to be 0, so this is going to be an indeterminate. So now I got to apply L'Hopital's again. The limit as x approaches 0 coming from the right. The derivative of this would be negative 2x all over. The derivative of tangent of x is secant squared of x. Let's write it that way. Think about secant. The cosine function is this way, right? So the secant function okay, so the secant function of x, this is going to end up being 1. So this is 1 squared, which is 1. Negative 2x, direct substitution, this is going to be 0, so our answer here would be 0.